afternoon, dear students. How was your exam? So today we discuss the afternoon session, computer science questions and their corresponding solutions. So the DS question is given. A is the set of first three elements by traversing the PFS and B is the set of elements by traversing through DFS. So what is the value of cardinality of A minus B? So we have just three. So A is the set of first three elements and B is also a set of first three elements. Now if we have to calculate the A set, we have 1, 2, 3. And when you traverse through the tree by the DFS, you will have either 1, 2, 4, 1, 2, 5 or 1, 3, 6 or 1, 3, 7. So like this, you have 1, 2 and 1, 3 in common. Two elements are common from A. So when you subtract A minus B, what you will get? The remaining element either 3 or you will have 2. So the cardinality of A minus B is 1. Now this next question of DOC. So you have to calculate the number of strings of length 8. So this is the initial state and the final state is QF. So we have to calculate the 8, length of 8. So 0, 0. Then we have two combinations 0, 1. Like this you are having 0, 1, 1, 0, 1, 1. So here we are getting all the combinations of 0 and 1 of the length 3. So 2 raised to 3. We are getting 2 raised to 3. And at the last you are having the loop for 0 and 1. We can take any number of zeros and ones. As we have given the length of 8, so either you can directly get 2 raised to 8 as 256 or another we are obtaining this 2 raised to 3 equal to 8. So remaining 5, this is for 3, remaining 5 we are getting this 2 raised to 5. So 2 raised to 3 into 2 raised to 5. So this gives out 2 raised to 8, 256. So 256 strings of length 8 are possible with this DFA. Now the next question, you are given a code in foo. If it equal to x and y are 1, return 1, and if x equal to 1, it is returning x, and otherwise we are recursively calling this function. So the function we are to use the values 15 and 255. So in the initial condition y is greater than x, that is 255 is greater than 50. So when y is greater than x, we have to call foo with x and y minus x. So x is 50, 255 minus 5 is 240. So likewise, every time we are getting the y is greater than x, so number of times we have to call this function foo, and at the end, second last point, we are getting this as 15. So as x equal to 1, we are executing these lines. So return x, that is the value as 15. So this is the answer for this question, 15. Let's see another question. This is based on the multiplexer. So we are given the sum of product equation x, y, z. Mean terms are given n0, n1, n3, n4, n5 and 6. So what is the correct implementation of this given function f? So to solve this, we have to construct the truth table for this. We are given the variables x, y, z and the mean terms given, that is the value as 1. So m0 is 1 and 1 is 1. As m2 is not given, it is 0. m3, m4, m5 and 6 are 1. m7 is not given, so it is also 0. Now, let's see the options. In the option, we have the 4 inputs in terms of x and y, z are the select inputs. So, based upon the value of y, z, we have to find the input to this function. So, we need to combine this y, z. So, let's see for 0, 0. This is the output. So, for 0, 0, analyze what you. For y, z, we are getting for 0, 0. Both the output f is 1. So, we can write here 1. Now, for 0, 1, 0, 1, 0, 1. Here is 1, here is 1. So, for 0, 1, again we are getting 1 as the output. Next, for 1, 0, 1, 0, here is 1 and here is 0. So, in this case, we are getting the two different outputs. So, we have to, let's check back to the value of x. So, this is 0, this is 0, this is 1, this is 1. That means we are getting the value same as the x. So, we can write here for 1, 0, x. Now, the last pair for 1, 1, here is 1 and here is 0. That means again we have to look back to the value of x. So, 1, 0 and when here is 1, it is 0. That means it is the complement of x. So, we can write for 1, 1 x bar. Now, we can use these values to design the function f with the marks. The 4 inputs 1, 1, x and x bar. So, A is the correct answer. Like this we have the different options, but the correct answer is 1, 1, x bar with the select lines y, z. The next question is given as the relation R. A relation R is given and for this relation, a relation must have at most one foreign key. So, whether this statement is true, and a foreign key cannot be used to determine a tuple. A foreign key can be used to determine a tuple? No. And the first statement is also false. So, a relation can have more than one foreign key. No limit on the number of foreign keys. So, both the statements are false. Another question is given, what is the worst case time complexity for the mean key to find out the maximum element from the mean heap? So, if you are finding the maximum element, suppose this is the mean heap for example. So, we have to go to add every node to find out the maximum element. That means if the tree is containing n number of elements, to find out the maximum element from the mean heap, we have to search for the n number of nodes, and so the complexity is big O of n. So the answer is big O of n. I have also uploaded the aptitude questions for this afternoon session. Please follow the link in the description box. So let's see the another question asked was, for the binary search, when the binary search is applied on an sorted, what is the worst case complexity for the arithmetic operations to be performed? So the complexity is log n. The binary search, for the binary search, it is log of n. The next question asked is regarding to the big Indian notations and the little Indian notation. So we have to find out the correct little Indian notations which is greater than 255. The options are given 0 cross 001, 0 cross 0100, 0 cross 6665, 0 cross 4342. Now in the little Indian we have to swap this LSBs and LSBs. So when you swap this 0100, this is wrong, and so option A and option D, these two options are correct. There is another question which is based on the probability. Some red color balls we have to put in the bags and something like that. I could not recall this question as I have not saw this. But there is a question. If you have this question, please comment the question. The next question is on the TOC. Two statements are given regarding the regular languages. S1 is every infinite regular language is undecidable language. Every infinite regular language is undecidable. So as it is infinite, so it is not always possible to find out the solution for this, algorithm for this R-Turing machine. So this statement is true. Then the S2 statement is given. Finite language is always regular. Also, second statement is true. So the correct answer is both S1 and S2 are true. In the next question, again the question on TOC, the context-free language, we are given W is a string and WR is the reverse of this W. So which of the following is the CFL? The options are given. WX, W reverse X reverse, such that WX belongs to AB star. B, WRX X reverse, WX X reverse, W reverse, WX, WR. So as we know that we can use the PDA to solve CF as context-free language. So when you push W, you push X, and as the precedence is not maintained here after W, whole extremes are pushed and then it is reversing the WR. So it is very difficult or not possible as on the top there is X. So how to plot this W reverse? So this A is not correct answer. It is not possible. So next option B. In this case, when you insert the W, for WR you can pop this A, B, A. Again you insert the X in the stack. You can pop out the X reverse elements. At the end you will get the empty stack. So this is a context-free language. Again for this, you pop the elements of W, A, B. Again you pop the elements of X. X reverse, on X reverse you pop these elements on. The next comes W reverse, so B, A gets popped and the stack becomes empty. So this is also a CFL. For this, we can mark X. So when X appears, pop the elements of the string. So again, this is a valid CFL. It can be implemented. So the options B, C, D are the correct options for this question. Another question of TOC. L1 is a regular language and L2 is a CFL. So which of the following is true? L1, L2, var and var. So this is a CFL. As we saw in these, we get L1 double var intersection L2 double var, which gets cancelled. So L1 intersection L2. This is CFL. L1 union L2 union L2 var. This is also a regular language and is a CFL. L1 intersection L2 union L1 bar intersection L2. Again, this is a CFL intersection and union operation. L1 intersection L2 bar. L1 intersection L2 bar. As it is not closed under intersection and the complement, this is not CFL, it is CSL. Here we have given the code int main integer x. We know that we write int of x. So this is the syntax error. So which phase detects this error? Lexical analysis. In the lexical analysis is just list out the tokens in the code, that is int main, this integer x, semicolon and all. So this is not the lexical analysis, semantics, and this option is not correct. So the answer is A1, that is the syntax analysis. The next question, the functional dependency given P implies QR and RS implies T. So which are the functional dependencies inferred from these two FDs? So P implies R, we find the P closure as PQR. So this is the implied FD. Then R implies T, R closure is only R, so it is not the implied PST. PS closure includes PQRST. So this is also the implied FD, and P implies Q. So it is also inferred from this. So this is the MSQ question. Now the next question is f of x is continuous on minus 3, 3. There is the discrete derivative of f of x which is less than or equal to 2. F of minus 3 is given as 7. The value of f of 3 we calculate. So the f dash of x is equal to f of 3 minus of f of minus 3, 3 minus of minus 3 less than or equal to 2. When we solve this, f of 3 minus f of 3 is given as 7. So put the value of 7, this is 3 plus 3 is 6 less than or equal to 2. So f of 3 minus 7 is less than or equal to 12. F of 3 is less than or equal to 12 plus 7, 19. the answer is 19. The maximum value for this f of 3 is 19. The next question is based on the probability. There is a coin, and when the coin is tossed, the probability of getting the head is P of S as 0.4. The coin is randomly tossed the number of times, that is 1000. So what is the standard deviation that you have to calculate? Let's see, the probability of getting the head is A, that is 0.4. So not getting the head is 0.6. 1 minus 0.4, that is 0.6. The number of times the coin toss is 1000. So the variance is equal to n into A into P. So when we put the value in this, we are getting here 1000 into 0.4 into 0.6, 24, 0, 240. So the standard deviation is the square root of variance, square root of 240, and what is the square root of 240? That is the final answer for this standard deviation, 15.49. So this is the answer for this question number 10. There is another question on redo and undo operations of the recovery system. I have not solved this question, so I cannot put out the complete question.